Today we're going to start talking about solving quadratic equations by formula. At least that's the title of your worksheet, right? But we're not quite going to get there yet today because there's some background information that I have to share with you, that I have to tell you first before we can go start solving it by formula, okay? The main thing that you need to know about is this right here. Okay? That's an I. In case you were confused. Okay? That's an I. In the middle of your worksheet, it says that I is the imaginary unit and we designate it by I. Okay? We are not going to be taking imaginary tests. We're not going to be getting imaginary grades. Okay? The imaginary unit is used in conjunction with several things I'm going to show you here in just a little while. But I need to teach you about the about I before we can start. Okay? I just tells you that that part is the imaginary part. Again, I think that'll make more sense here in just a moment. Okay? There's two ways you can define I. And again, if you look about halfway down on your worksheet, it has a capital or italicized I, and it says the imaginary unit is designated as I. There's two ways we define I. The first way is I is the number you can square to get an answer of -1. So we need to be able to translate that English sentence into a math sentence. I is the number you can square to get an answer of -1. I is the number you can square to get an answer of -1. Okay? Excuse me. Do you see on your worksheet where it has that sentence and then it has a column that says symbols? That's what goes in that blank. Okay? Then right underneath it, it says I is the square root of -1. Can you translate that from an English sentence to a math sentence? I is the square root of -1. I is the square root of -1. Does that make sense? Yes or no? Okay. So what's happened in the past is I say to you, what's the square root of 25? And you say 5. And then I say, okay, then what's the square root of 36? And you tell me the answer is 6, right? And then I give you a really hard one and say, what's the square root of 100? I was just teasing about that being a hard one. 10, right? Okay? And then you got to a problem like this. And we said, no real solution. Why did we say no real solution? Can you take the square root of a -49? Press it into your calculator, please. The square root of -49. That's what mine says. Non-real calculation. And then it gives you an example. If you try to take the square root of -1, it's invalid. Okay? Does that make sense? See, I tried to take the square root of -49 and it says non-real calculation. That's why we've always put no real solution over here. Except there are solutions. You know that because of what we talked about yesterday or the day before when we talked about the fundamental theorem of algebra. Do you remember that? And I said in the fundamental theorem of algebra what it says is if we have a quadratic with the degree of 2, of course that makes it a quadratic, right? It has a degree of 2. Then I should have how many solutions? 2 what kind though? Do you remember? 2 complex solutions. Well, now is when I get to define that word for you. You remember I told you got to trust me for a couple days about that? Today is the day I tell you what it means. A complex number doesn't mean it's a hard number. Okay? I know that the definition of complex, one of the definitions is difficult, right? Complex in a math situation means there's a real part and an imaginary part. And that's going to come from right here. When we end up with the square root of negative number, you're right, there's no real solution. But today I'm going to teach you how to find the imaginary ones. Okay? So let me show you some stuff first of all. Okay? Actually, we'll just jump to this worksheet, bottom page, bottom part. Here's some example problems. First thing I want you to know, though, however, is some properties of square roots that you may or may not remember since the last time you talked about square roots, which was either 8th grade or 9th grade. Okay? If I'm taking the square root of negative 49, because of properties of square roots, I can say that that is the same as negative 1 times 49, the square root of negative 1 times 49. Do you agree with that? Are those two things equal? Okay? Because of the properties of square roots, I can also do this. I can separate those into two separate square roots. What is the square root of negative 1? We just said, right? The square root of negative 1 is I. What is the square root of 49? 7. So what is I times 7? It's just 7i. Okay? So that's where, for this blank, that's where we get 7i. So then tell me what you... we need to check this. I need to make sure you understand what's happening here. Okay? If we check this, I would figure out what was inside the root by squaring it, wouldn't I? 7i, which is the same thing as 7i times 7i. What is 7 times 7? 49. And what is I times I? I squared, right? Well, what does I squared equal? Negative 1. So what is 49 times negative 1? Negative 49. Yes, ma'am.
Can we use the I squared and like the first step? Don't we just use I?
We just use I. Anytime it says the square root of negative 1, we just use I. Okay, good question. So what about this one right here? So what's the square root of negative 121? 11i. Okay? Now, do you notice how beautiful I write my i's? That was just a joke, by the way. Okay? When we write I representing imaginary, we're supposed to write it in italics. I don't know how. So I just write mine in a little cursive I. Okay? If you write it just like a stick I, like that, do you see how much trouble that can get you in? Is it a 1? Is it an I? If I forget to put my dot or if I put it really light? So please go ahead and write yours like a little cursive I. Okay? I don't know who Lily is. I was just drawing stuff. Sorry. Okay? So how do I... Let's check this one. How do I check it? Square it. So that's 11i times 11i. What's 11 times 11? 121. What's I times I? I squared. And what's what is I squared equal to? Negative 1. What is 121 times negative 1? Negative 121. Okay? So can we do some with some different operations within? What about the square root of 17 minus 42? Yeah, I got to do what's inside the radical first, right? What is 17 minus 42? Negative 25? So this equals the square root of negative 25. And what is the square root of negative 25? 5i. Okay? Now remember back for just a second what I told you about the properties of square roots. Can I rewrite problem D? Can I rewrite it as -1 times 3? Which is the same as the square root of -1 times the square root of 3? What is the square root of -1? What's the square root of -1? I. What's the square root of 3? I don't know either. It's not a nice integer number, not like a nice whole number, so I just want to leave it as square root of 3. Okay? Any questions about that one? All right, so what about E? Where should I start? I can't divide 12 by 2 yet. I should figure out the square root of -36 first. So I have 12 plus 6i all divided by 2. So now I add 6i and 12? Is that what you're saying? Okay, so can you add real parts and imaginary parts? The only place I know that worked was in Enchanted, right? Where you add real parts and imaginary parts. Also, Who Framed Roger Rabbit, but I don't know if you guys know that movie. Okay? That's the only place it worked, though. It can't work here. We cannot combine real parts and imaginary parts. Okay? I is not a variable. I'm not going to put something in later on for I, but it follows all the rules of variables. Okay? I can't add 12 and 6i because this is a real part, this is an imaginary part. Can I divide them? Yes, because it follows the same rules as variables, right? I can do that. So is everything in the numerator divisible by 2? So then divide it both by 2, and what do you get? 6 plus 3i. Okay? So I can say 4i, oh, that was my favorite. That was my nickname when I was little. 4i plus 3i equals 7i. I can do that, right? Uh-huh. I can do 8i divided by 2 and get my favorite one again, right? 4i. Okay? That's just a little joke, because if you wear glasses, sometimes people call you 4 eyes. That was my nickname when I was little. It was such a wonderful nickname. It's okay. It wasn't your fault. You didn't call me that.
So what if you have 8i divided by 2? Would it just be... No, it's not.
8i divided by 2 is 4i.
It doesn't matter if you have...
I can divide... No, it's okay. I can divide imaginary parts by real parts. But I can't add or subtract imaginary parts and real parts. I can only combine like terms. Mm-hmm. Mm-hmm. I don't know. I think you probably should be able to. Okay? Yeah, don't worry about it right now. Okay, go to the next page and let's do some more applications here. Okay? So to be clear, I defined it for you earlier, but here's what's actually defined on the paper. A complex number is the sum of a real number and an imaginary number. It's usually written in the form a plus bi. The real part is a. The imaginary part is bi. Now they called this the sum, right? It's the sum of a real number. But is it okay if I put plus or minus right there for you? Because it could be a minus bi. That's still taking a sum because you're adding the opposite of the imaginary term. You okay with that? Okay. So let's go through some of these. What it's asking us to do is put it in this exact form. Very rarely are you going to be asked to do that. You're just going to be able to use them. But right now I need to make sure you can recognize both the real part and the imaginary part. So I'm going to have you guys put this into a plus bi form and then identify the real parts and the imaginary parts. Okay? So simplify it first if we need to. Okay? Do we need to simplify this? If I need to get it into the form a plus bi, what do I need to do? 25 plus 0I. Okay, for the record, that does not say oi. That's 0I. Okay? Do you see now how I have a real part and an imaginary part? Did I change the value of the 25 by adding a 0I? No. That's the only thing I can add, right? Is a 0 that doesn't change its value? Okay? So which is the real part? 25 is the real part. What's the imaginary part? 0I. If I just put imag, are you going to know that means imaginary?
Yeah, I did that.
You did that also? Okay, then I'll follow your lead. Just write imag. You? Oh, you want me to say your name on the recording? Look at letter G. I almost said look at G, but I didn't want Hayden to think I was talking to him. Sorry, I was just teasing about that. Okay. So I need to write this in A plus BI form. How does it go? 0 plus 25I. Excellent. What's the real part? 0. What's the imaginary part? Any questions about letter G? What about H? H is already finished. It's already in the right form, isn't it? So we just... Perfect. 3 is the real number. Negative 5I is imag. Questions? I. Problem I. What is the square root of negative 144? 12I, right? So I have this equals 9 plus 12I divided by 6. There's 2 different ways to do this problem, and I'd like to show you both ways. Okay? First of all, I could take 6 and divide it to each term in the numerator, couldn't I? What is 9 divided by 6? It's 1.5. Good. What is 12I divided by 6? 2I. Which is the real part? 1.5. What's the imaginary part? Good. So that's one way to actually do the division, right? Can you think of another way we might do this? What if we just simplified the fraction? Is every part of the fraction divisible by the same thing? What about a 3? Okay, so if I divide each term by 3, I get 3 plus 4I, that's my favorite again, over 2. What's the real part? That is the real part. 3 over 2. What? Because it tells us to simplify first. Right there. Okay, so I have to simplify first. What's the imaginary part? It's this, isn't it? Everything in the numerator is divided by the denominator, right? Oh, it looks like a heart. Yay. But that's the imaginary part. Okay? What about J? You're going to combine like terms. And when we're talking about like terms this time, we're not talking about variables and non-variables. What are we talking about? The i's and the regulars, the reals and the imaginaries, right? Okay? So if I combine the reals, I get, good, negative 4 plus 13, I. And so we know that this is the real part, and we know this is the imaginary part. We're not even to the easiest thing we've ever learned yet. That's next. You ready? Yes. Let's finish K. K can be tricky if you let it. Don't let it. What? Close. That's just not what it's called, but you're thinking of the right thing. Distribution. Distributive property. 6 times 6. 36. 6 times negative 2i. Negative 12i. 6 times negative 2? Yeah. Okay, 2 times 6. Sorry, 2i times 6. So plus 12i. And 2i times negative 2i. Hey, it's my favorite again. Okay. Oh, is it though? What's I times I? I squared. Okay. Tell me what's happening right here. Tell me mathematically what's happening right here. Negative 12i plus 12i equals 0. It goes to 0. Somebody please tell me what I squared is. I squared equals negative 1. What is negative 4 times negative 1? That's a positive 4. I have 36 plus 4. 40. So, wait, I have to answer this question. He said, why isn't there an I? Well, first of all, right here, these two I terms, these two imaginary terms went to 0, didn't they? Because I had a negative 12i and a positive 12i. That's 0. Those are gone. What is the value of I squared? Negative 1. What is negative 4 times negative 1? That's a positive 4. There's no i's involved left. Okay? So this is the real part, but if I want it specifically in a plus bi form, what needs to be there? 0i. And that's the imaginary part. Okay? Okay, are you ready for the easiest thing we're going to do all day? Complex conjugates. How difficult does that sound? Very. Okay? Which one of these problems right here looks the most difficult to you? P? Okay, we're going to do P first. I did not say we are going P first. I said we're going to do problem P first. Oh my gosh. You guys are 7. Okay? Are you ready? If your number is 2/3 minus 1/5 I, the complex conjugate is 2/3 plus 1/5 I. Look at Q. Look at Q. 5 plus I root 3. The complex conjugate is 5 minus I root 3. I'm switching the sign on what? What am I switching the sign on? The I, the imaginary part. What did I do with the real part? I left it alone. Look up here in this box. The real parts are the same. The imaginary parts are opposite. Kirsten, which one do you want to do?
I want to do letter N.
Number N? Okay, go ahead and tell me what you think it is.
Is it negative 3 minus 6?
Perfect. Negative 3 minus 6i. Which one you got?
No, 2 conjugate. We don't need like 2.
Okay, time out. You're fine. We are not conjugating a verb here. Okay? It might look like the same word. It's not the same word. We are finding the complex conjugate. I don't want you to get confused and think we're doing some sort of verb conjugation here. Because when I was in high school, I did not like to do verb conjugations. I understand their importance. I do. Okay? Doesn't mean I had to like it. Just like the way some of you guys feel with some of the math we do. Fair enough? Okay? We are not doing conjugation. We are finding complex conjugates. And the way we find complex conjugates is we leave the real part alone and we change the sign of the imaginary part. Does that answer a question for real? Okay. Tell me what O is. Negative 12 plus 5i. Tell me what M is. Negative 25i. Does anybody have any idea what L is?
25 minus OI. Is it just 25?
It's just 25. If we put anything in there, yes, it would be a 0i, but we don't. There's no sign to change there, so we can just leave it 25 because it's the real part. The real part stays the same. Just a little. You ready? I want to show you a situation where something like this might come up. Okay? So, solve 6x squared plus 96 equals 0. This is a simple quadratic. And the reason it's called a simple quadratic is because it only has one variable, and it's the x squared. There's no other x in here, is there? Okay? So we're going to solve this exactly the way we would solve any other equation by getting all the x's on one side and all the numbers on the other side. Fair enough? I would minus 96 first, absolutely. 6x squared equals negative 96. Divide both sides by 6. X squared equals negative 16. First, we have to take a commercial break. You ready for a commercial break? Please tell me the answer to that. So let me make sure my question is clear to you. I'm saying, what number times itself equals 25? I agree with that as the answer. However, it's not the only answer. What else times itself gives you a 25? What times itself? Negative 5. I'm not sure why you're wooing me as if I was a horse. Do you agree with me that 5 times 5 equals 25? Do you agree with me that negative 5 times negative 5 equals 25? Okay? So if I'm asking you what the square root of 25 is, yes, it's 5. Okay? But I also need you to keep this in the back of your mind because of that danged fundamental theorem of algebra. Because if we're solving an equation like this, how many answers should I get? 2. And when I go to take the square root of both sides, back to the show. Commercial's over. When I go to take the square root of both sides, I'm going to get x equals, I would get 4i. What times itself equals 16? Positive and negative 4. And we can write it just like that. Okay? So if I am the one to put in the square root sign into the problem like I just did, I also need to remember to put the plus or minus as well. Okay? Last thing I want to ask you before I tell you your homework is this problem right here. What do you notice about the two answers? Please understand that's one answer and that's one answer. Right? What do you notice about those two? They are conjugates of each other, aren't they? Yes? Okay. Do you know why they're complex conjugates of each other? Because I don't know. Okay. Okay. Please notice that one of them is positive and one of them is negative. Doesn't that make them complex conjugates? Yeah, that's why they're complex conjugates. Okay? Yes, they are. If the imaginary parts are opposite. When you turn the paper over and you see chart A, you see your homework. Okay? Listen to me, please. 1 through 7 is required. 8, 9, and 10 are extras. Okay? Do I need to walk you through number 1 so you understand what to do? Simplified is 11i. The real part, there's not one. Imaginary part, 11i. Complex conjugate would be negative 11i. You get the idea?
So number 2 for the complex conjugate, it's 56.
Yes, negative 56.
Simplified is 56.
What's simplified? Negative 56. What's the real part? Negative 56. What's the imaginary part? There's not one. It's still negative 56 because the only part of the number that changed the sign is the imaginary part. Okay? Any questions on this? Are there any questions on this? Peace.